Okay, so the purpose of this experiment is to titrate the prepared calcium hydroxide solution with the standard hydrochloric solution, and by determining the molar concentration of dissolved hydroxide ions in the saturated calcium hydroxide solution, you'll be able to calculate the KSP. The formula for this reaction is given right there.
Number 1 asks to calculate the hydroxide concentration from the results of your titration and explain your calculations. So to calculate the OH concentration, we use the formula MaVa equals MbVb. And the acid we used was hydrochloric acid, and the given molarity is 0.05 molar. So we know the molarity of the acid is 0.05 molar. And after the titration, we used 6.37 milliliters of acid. So we know the volume. And the base is calcium hydroxide. The molarity is unknown. And the volume is given, which is 10 milliliters. So with this information, we plug it into the formula. So we get 0.05 times 6.37 equals X times 10. And so when you solve for X, you get 0.3185 equals X times 10, and you divide by 10, and you can find that Mb equals 0.0319. So that is your hydroxide concentration.
Okay, now for number 2, to get the concentration of the calcium 2 plus ion, I'm going to erase this. You are going to use stoichiometry with the coefficients given in the reaction equation right here. Okay, so you take that number that you just found, the molarity of the hydroxide ion, and you divide it by 2 moles of hydroxide, because 2 moles makes 1 mole of calcium 2 plus, according to our balanced equation. So if you solve that, divide 0.0319 by 2, you should get 0.01595 molarity. So your concentration of Ca2 plus is 0.01595. Okay.
And number 3 asks to calculate the KSP, and the KSP general formula is products over reactants, but since our reactant is a solid, you don't include that in the equation. So in this case, the KSP formula would be Ca2 plus times OH minus squared because of the 2 there. So if you plug in the numbers that we just found, you have 0.01595 times 0.319 squared. And when you put that into your calculator, you get 1.62 because of sig figs times 10 to the negative 5. And KSP doesn't have units, so that is your answer.
Okay, so the accepted value of the KSP for calcium hydroxide is 2.07 times 10 to the negative 5th. So ours is close but not exactly correct. So a source of error here, our KSP value was lower because we might have titrated too much hydrochloric acid, which may have increased the equivalence point. So that's one source of error here. Other than that, yeah. Thank you.